Now that we have matrices, we might want to do something with them. We might think about doing algebra with them. So possibly adding matrices, subtracting matrices, multiplying by various quantities. So the first element of matrix algebra that we might want to look at is if we've got two matrices A and B, what does it mean to say they're equal? So what does it mean when we say A equals B? Well, what this means is, well, two things really. A and B have the same size, i.e. they've got the same number of rows and the same number of columns, and also that the element Aij, and remember what I mean there is this is the element that's in the ith row and the jth column. So the element Aij equals the element Bij. Okay, so it's rather long-winded way of saying that just every element is the same as the one in the other matrix. We just look across. Let's do a quick example of that. Let's imagine we have a matrix A, which is A, B plus C, C, and 4. Well, I'm not told you what A, B, and C are here. And I've got another matrix B, which is, let's say it's 4, 1, 2, and D. Okay, just some random numbers putting in there. I've not told you what A, B, C, or D are. If I say that A equals B, what does this mean? This means that every element has to be equal to its associated element in B. It means that A has got to equal 4. B plus C, this element here is actually the sum of two numbers, B plus C. That's got to equal 1. This element here has got to be the same as this element. So the second row, first column, has got to be the same as the second row, first column. C has got to equal 2. And finally, this very last element, 4, has got to equal D. And from this, I should be able, well, I can work out all these different numbers. I've got A equal to 4. This tells me C is 2. Here I've got D equals 4. This last one, I need to do a tiny bit of work. I know that C is 2 and B plus C must be 1. It means B's got to be equal to minus 1. So I can have matrix equations like this. And from this, I can work out information from the various matrices. Okay, so the next aspect of matrix algebra, if I have a matrix here, 1, 2, 3, 4, 5, 6, and I want to think about what 3A is. A is this matrix. So this multiplication by a scalar, 3 here is just the scalar, the number 3. And all I do is I multiply every element by 3. And I find my new matrix just by doing those multiplications like that. Well, there's one particular example I want to mention, and that's working out minus A. So minus A really is just minus 1 times A. So I multiply every element by minus 1. I negate them and make them all a different sign. So minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. So instead of an array of values 1, 2, 3, 4, 5, 6, this is now an array of values minus 1, minus 2, etc. The next thing we might want to consider, if we've got two matrices, A and B here, I've just given you examples of square matrices, 2 by 2, 2 rows, 2 columns. What I might want to work out is the sum of A and B, A plus B. Well, it turns out that it's relatively easy, and it's as you might expect. A plus B, let's call it a matrix C, is really just calculated adding up the corresponding elements. So this first element, the first row, first column, would add to the first row, first column in B. Okay, so 1 plus 2, 0 plus 3, 2 plus 5, and 3 plus 6. I stay as having a 2 by 2 matrix And there it is. And the key thing to realise here is that when I'm adding two matrices together, this is only possible if the two matrices are of the same size. It's 2 by 2, 2 by 2. It's only possible to add the elements up like this if my two matrices are the same size. If I want to subtract matrices, let's say I want A minus B, then actually what I think of is really the sum. But it's a sum of A and minus B. Minus B being B times minus 1. I know how to multiply B by minus 1. I make every element the opposite sign, i.e. negative here. And so this would be this matrix A, 1, 0, 2, 3, plus minus B. I add those up in the same way. I get 1 minus 2, 1 plus minus 2, 0 plus minus 3, 2 plus minus 5, and 3 plus minus 6. And that's my final matrix for A minus B.